Hello everyone, my name is Frank. In this video we're going to take a look at my Activity 4 project for my Embedded Systems course. The purpose of this project is to have a cruise control functionality. It is an extension of the previous ones in that it mostly the same. You take a analog input to a PDO pulse width modulation output, which drives through this transistor array, drives a motor with the battery, and then we take input capture on one end of our motor, which lets us find the frequency, and the RPMs, which gets output to the LED, or LCD rather. So the addition to have cruise control and to verify it, we have a switch here, which is used to toggle cruise control on and off, and then we have a potentiometer, 100 ohm potentiometer here being used as a rheostat. Never actually said that word out loud before, but using it as a variable resistance to in lieu of physical resistance for the motor to verify that the cruise control is actually working. Okay, so here we have cruise control disabled, and we can just turn the, gotta start it. Turn the potentiometer, and so here on the LCD, it's kind of hard to see. So we have, as previous, we have the frequency and the RPM on top, frequency on bottom. This 0 here is the value of our flag for cruise control, and what is 0.0 right now here, that's the frequency target. So the way this works, when we toggle the cruise control on, it will save the current frequency and it'll output it here, and then it will try to maintain that, and it will ignore the potentiometer input here, analog input. So let's toggle it on. So now 26.3 is our target frequency, and you can see turn potentiometer has no effect on the speed of the motor, and our flag is on. So now to test that it is working, adjust our our variable resistance here. So I turn it up, and you can see it comes back to the desired frequency. And so for debugging purposes, this has you may have caught, I'll do it again. There's a plus here if it's increasing, and a minus if it's decreasing. And then there's also there's a bit more logic behind it. There's a check to see if it's over 20% above or 20% below the desired frequency, and at that case it will accelerate or decelerate the motor faster. So that is signified here as a plus or minus for the normal one, and then an up arrow or down arrow for the faster acceleration. So let's see. Let me turn it this way. So you saw there, I turned the resistance down, so we were going faster, and then there was a minus and a down arrow, so it reached 26.3 revolutions per second faster. And you can see, so I'll turn it down, or turn up the resistance again, and you see there it's going much faster to reach our desired, and now it went over, so it's decreasing, and now we're at balance. Oh, and to show that it can go off, let's turn the potentiometer up a bit. There are input potentiometer, which is being ignored. Toggle the switch off, and now we're going based off that. Except we're not. Why are we not? Oh, because the resistance is too much. So Yeah, that's about it. Thank you for watching.